So here in this problem, we have a line 5x minus y equals to 3 that is tangent to the circle at a point 2, 7. And also it's given here that the center of the circle lies on another line with the equation x plus 2y equals to 19. We need to find out the equation of the circle. So let's begin. First, we'll try to understand the problem graphically. Let's say we have a circle which is centered at C, and through the center passes a line with the equation x plus 2y equals to 19. Then we have a line which is tangent to the circle. The tangent line has the equation 5x minus y equals to 3. It is tangent to the circle, let's say, at the point A having the coordinates 2, 7. Our goal will be to find out the equation of this particular circle. How shall we do that? Now, what we'll do, we'll use the equation of a normal line to find out the coordinates of the center of the circle. Because if we have the equation of the tangent line, we can easily find out the equation of the normal line. And we know that a normal line is going to pass through the center of the circle. So this is going to be the normal line whose equation that we need to obtain from the equation of the tangent line. So let's use the equation of the tangent line first. We have 5x minus y equals to 3. So from this particular equation, we can rewrite it as y equals to 5x minus 3. And if we compare it with the slope-intercept form, which is y equals to mx plus c, then the slope comes out to be equals to 5. This is the slope of the tangent line. Now, we want to find out the equation of the normal line. And since the normal line passes through the point A 2, 7, we can easily find out its equation using the point slope form. However, we will also need its slope. To find out the slope of the normal line, we'll say the slope of the normal line is going to be simply, let's call it m1. It will be simply the negative t reciprocal of the slope of the tangent, because the normal line and the tangent line are perpendicular to each other, and by the properties of straight line, the product of the slopes must be equals to -1, which means that the slope of the normal is going to be -1 over 5. Now, we can find out the equation of the normal. So equation of the normal is going to be, so we'll use the point slope form, which is given by y minus y1 equals to the slope m1 times x minus x1. Now in that case, x1 comma y1 corresponds to 2, 7. So we have y minus 7. That's the value of y1 equals to -1 over 5 multiplied to x minus 2. Okay, so let's multiply throughout with 5. So we get 5y minus 35 equals to negative times x minus 2 will be negative x plus 2. When we rearrange the terms, we get the equation of the normal, which is x plus 5y equals to 37. But we're going to label this as equation number 1. The whole reason we wanted to find out the equation of the normal, because we can clearly see that the normal line is intersecting the line x plus 2y equals to 19, which passes through the center. So if we solve the two equations, then we are going to get the values of the intersection point, which is nothing but the coordinates of the center C. Okay, so let's take the equation of the line, which is x plus 2y equals to 19. We have x plus 2y equals to 19. We're going to label this as equation number 2. So what we'll do, we will subtract the two equations. So x and x cancels out. 5y minus 2y will be 3y. Now 37 minus 19, that will be 18. Which means that the y value corresponds to 6. Now that we have the value of y, we can easily find out the value of x by using either equation 1 or equation 2. Let's use equation number 2. So here, the value of x will be equals to 19 minus 2 times y, which means we have 19 minus 2 times 6. So we get 19 minus 12, so that will be equals to 7. So that means our x value is 7. Now that we have the value of x, which is 7, and y equals to 6, we have the coordinates of the center. We have 7, 6. We have the coordinates of the center C. We have the coordinates of the point of contact A. We can easily use the distance formula to find out the length of CA, which is nothing but the radius of the circle. Now, radius r will be given by the square root of, so what we need is the square of the difference of the x coordinate, and we'll add it to the square of the difference of the y coordinate. Let's start with the difference of the x coordinate. So we'll do 7 minus 2, and the difference of the y coordinate will be 6 minus 7. This will be equals to 7 minus 2, that's 5. 5 squared will be 25. So x minus 7, that's -1. Squaring it gives us +1. So that means our radius comes out to be square root of 26. Now that we have the radius, we have the coordinates of the center. So therefore, the equation of the circle, what we'll do, we will use the standard form, which is x minus h whole squared plus y minus k whole squared equals to r squared. So h comma k, that's nothing but the coordinates of the center of the circle. So h value corresponds to 7, k value corresponds to 6. We have x minus 7 whole squared plus y minus 6 whole squared equals to the square of the radius, so that's going to be 26. This is going to be the required equation of our circle.